Hello everyone, welcome to Sri Vlogs Fun and Edutainment channel. We provide you education with entertainment. Right students? In today's class we will discuss two more very important problems about harmonic functions. Right? Here it is question number 1. Prove that u equal to y cube minus 3x square y is a harmonic function and determine its conjugate harmonic function. Find the co-corresponding analytic function f of z in terms of z. Clear? Right. So here in this question, three steps are involved. The step number 1 is proving the given function is harmonic function. Step number 2 is determining its conjugate harmonic function. And step number 3 is finding the analytic function corresponding to the given u. Okay. So step number 1, proving the given function. What is given to us? U equal to y cube minus 3x square y. Okay, here given that u. Now we have to prove this u is a harmonic function. Already we have discussed about harmonic function in first video, right? So I will give the link in the description, but I am repeating the process of proving harmonic function once again. Please listen carefully. So if u is a function, then the process of proving harmonic function is del square u. Del square. What is this del square, sir? Del square u is equal to 0. Then u is harmonic function. Del square means partial differentiation of u with respect to x twice. That means dou square u by dou x square plus dou square u by dou y square. This is called as del. Del square u is nothing but dou square u by dou x square plus dou square u by dou y square equal to 0. That means if u satisfies this equation, that means dou square u by dou x square plus dou square u by dou y square equal to 0, then u is said to be harmonic function. Clear? Okay, so now what we have to do? Yes, we have to differentiate u with respect to x twice. That means 2 times. And also we have to differentiate u with respect to y 2 times, and we have to add those terms, and we have to get 0. Okay, this is the step number 1. Okay, so if this question is asked for 10 marks, this first step consisting of 3 marks. Okay, now we are finding dou u by dou x. So dou u by dou x is nothing but already we know clearly how to find the partial derivatives. Okay, dou by dou x of y cube minus 3x square y. Clear? So here it is x, here it is y, only y alone this function. Therefore the derivative of y with respect to x is constant. So that means 0. Minus 3y is constant here. 3y into dou by dou x of x square. Dou by dou x of x square. So x square differentiation is right 2x. So here minus 3 into 2 minus 6 xy. Again we have to differentiate with respect to x. That is dou square u by dou x square. That is nothing but dou by dou x of dou u by dou x. So dou by dou x of dou u by dou x is nothing but minus 6xy. So minus 6y is constant here. Dou by dou x of x. Dou by dou x of x is nothing but 1. So we got minus 6y. Dou square u by dou x square is minus 6y. Clear? Now similarly we are finding dou u by dou y. That is dou by dou x of y cube minus 3x square y. Okay? So dou by dou y of, sorry, dou by dou y of. Now with respect to y cube differentiation, right, exactly 3y square minus with respect to y 3x square treated as constant, y differentiation is 1, so minus 3x square into 1, minus 3x square into y differentiation is 1. Again we have to differentiate dou square u by dou y square, that is dou by dou y of dou u by dou y. That is nothing but dou by dou y of 3y square minus 3x square. Now 3 is constant, y square differentiation. Y square differentiation with respect to y is 2y. Minus 3x square is totally constant. So 3 2 ja 6, 6y. Okay, clear? Now add these two values. So take it as equation number 1. Take it as equation number 2. Add these two values. What we get? Dou square u by dou x square plus dou square u by dou y square, that is equal to minus 6y plus 6y. Okay, clear? So minus 6y plus 6y get cancelled, that is equal to 0. That means u is harmonic function. So step number 1 is clear. U is harmonic function. Because right, now coming to step number 2. So step number 2, we have to find conjugate harmonic function. Here u is given to us. So the conjugate harmonic function of u is what? Right, v. The conjugate harmonic function of u is v. Now we have to find the value of v. To find v, we have to take dv. Consider dv, the exact differential. So the exact differential formula we learned in our M1. Okay. So dv is equal to dou v by dou x into dx plus dou v by dou y into dy. This is the total differential formula. Okay. This is the total differential formula of v. dv is equal to dou v by dou x into dx plus dou v by dou y into dy. From this, in this expression, we are having dou v by dou x, dou v by dou y. But we don't have dou v by dou x, dou v by dou y. Then how to find v? Right. So here we can use Cauchy-Riemann conditions. Okay. So the given function is analytic. Then a function is said to be harmonic if it is only analytic. If it is analytic, then only it is harmonic. Clear? So that here we use the Cauchy-Riemann conditions. Okay, what are Cauchy-Riemann conditions? Clearly we know that dou v by dou x is equal to minus dou u by dou y. Clear? So in that we can write dou u by dou y is equal to minus dou v by dou x. But here we need the value dou v by dou x. So in reverse we can write it as dou v by dou x is equal to minus dou u by dou y. And dou v by dou y is equal to dou u by dou x. These are CR conditions. CR conditions. CR conditions. So from CR condition we can write these two values in the above equation. So dv is equal to dou v by dou x can be written as minus dou u by dou y into dx plus in the place of dou v by dou y we can write as dou u by dou x. Dou u by dou x into dy. Now minus dou u by dou y. Dou u by dou y is minus of 3y square minus 3x square into dx plus dou u by dou x. Dou u by dou x. What is dou u by dou x? Minus 6xy. Sorry, it is yeah, here it is minus. Already it is minus. Dou u by dou x, in the dou u by dou x it is minus. So minus 6xy into dy. Clear? Okay. So dv is equal to minus of 3y square minus 3x square into dx plus minus of 6xy into dy. Now RHS is of the form mdx plus ndy. Mdx plus ndy. If the equation is of the form mdx plus ndy, then if it is exact differential equation is nothing but dou m by dou y is equal to dou n by dou x. Then it is said to be exact differential. Dou m by dou y. So you have to do with respect to y this function. Minus of 3 into y square differentiation is 2y. Minus 6y. Okay, minus 6y. Minus 6y. Dou m by dou y. We have to differentiate this expression with respect to y. So if we do with respect to y, minus 3 into y square differentiation is 2y. 2 into 3, 6. Minus 6y. 3x square differentiation is 0. Okay, clear? Now we have to differentiate this function with respect to x. N d dou n by dou x. This is n. This is m. This is n. Okay, dou n by dou x. So dou n by dou x means minus 6y into dou by dou x of x. Dou by dou x of x is nothing but 1. So minus 6y into x differentiation is 1. So minus 6y is equal to minus 6y. That means dou m by dou y is equal to dou n by dou x. So if you observe, if you apply our logic, it is u is a harmonic function. Harmonic function in the sense dou square u by dou x square plus dou square u by dou y square is equal to 0. That means here in the place of m, what we write? Minus dou u by dou y. That means minus dou square u by dou y square. So in the place of n, what we can write? Dou u by dou x. That means dou square u by dou x square. Clear? So dou square u by dou x square plus dou square u by dou y square equal to 0. Already we have proved it. It is a harmonic function. That means always it is an exact differential. So no need of checking is it exact or not. So for understanding purpose only, I told it, I explained it. But here it is not needed to prove exact differential equation. It is by default it is exact differential equation because u is harmonic function. Because u is harmonic function. So if u is harmonic function, dou m by dou y is nothing but minus dou square u by dou y square. Dou n by dou x is nothing but dou square u by dou x square. Therefore dou square u by dou x square plus dou square u by dou y square equal to what? 0. Because it is harmonic function. Therefore dou m by dou y equal to dou n by dou x. Clear? Understood? Right. So it is exact differential. Now, what is the solution for exact differential? We learnt in our M1. Please remember that the solution for the exact differential equation by doing integration on both sides, integral dv is equal integration of m dx y treat as constant plus integral n dy terms not contain x. So after completion of integration you have to add constant plus integral n dy terms not contain x plus c. So it is the way of finding the solution for exact differential equation. It is learnt in our M1 first year. Okay. Now integral dv is nothing but v, that is equal integration of m dx. What is our m? So m is nothing but minus of 3y square minus 3x square. Okay, minus of 3y square minus 3x square. Okay, just we'll write m equal to minus of 3y square minus 3x square. Comparing this expression by m dx plus n dy, our m is minus of 3y square minus 3x square and n is minus 6xy. So our exact differential solution is integral dv is equal integral m dx y constant. While doing the integration for the first term, we treat y as constant, and plus integration of n dy not contain x terms. So while writing n, particularly in n, we have to choose only the not contain x terms. That means the term should contain only y terms or constants. It should not be contain x term. Right. Now integral dv is nothing but v, that is equal integral m minus of 3y square minus 3x square into dx plus integral n not contain x. So here it is x is there. So if x is there, we think of x, we are not allowed to take that value. So if not, there is x term, we consider the total term as 0. Okay, so 0 into dy. Clear? So if there is any x term, we are not allowed to take that term in the place of n, because integration of n dy not containing x terms. So we should allow to take only only alone y terms or constants. So if x term contains along with y, then we are not allowed to take that term. Please remember this point. Okay, now here we treat y as constant, so total minus 3y square is constant into 1 dx minus 3 constant into x square into dx plus 0 plus c. So minus 3y square 1 dx. What is the integration of 1 dx? X. Right, very good. Minus 3 into x square integration. Right, x cube by 3. X to the power of n plus 1 by n plus 1. Okay, plus c. Now this 3 and this 3 get cancelled. So minus 3xy square minus x cube plus c. So we have found v value. So step number 1 is over. Step number 2 is over. Now we have to find the analytic function f of z. That means we have in the given question u is there. U is given to us, and we have found v. So our analytic function is of the form f of z is equal to u plus iv. Clearly all you know. Our analytic function is of the form f of z is equal to u plus iv. But you have to find in terms of z. Right students, we got u is equal to y cube minus 3x square y, v is equal to x cube minus 3xy square plus c. Right students, in the previous step we did some mistake, that is minus 3xy square minus x cube, but we have to multiply that minus to the internal terms, then we get minus into minus plus x cube. Please remember that, minus into minus plus x cube. Please correct it. So here v is equal to x cube minus 3xy square plus c. Okay, now we have to find f of z. Clearly we know that f of z is equal u plus iv. So what is u? Y cube minus 3x square y plus I into v x cube minus 3xy square plus c. Okay, so if it is not asked f of z in terms of z, it is enough to do. We have to stop here only. But here it is asked that we have to find f of z in terms of z. So to find in terms of z, we have to substitute in the place of x, z and y equal to 0. This is the Milne-Thomson method. Okay, according to Milne-Thomson, finally you have to substitute in the place of x is equal to z, y equal to 0, then we get the value of f of z in terms of z. Okay, so f of z is equal to y cube, in the place of y 0, in the place of y 0, so 0 minus 0 plus I into, in the place of x z, so z cube minus 3 into y, in the place of y 0, therefore 0, so this is equal to I z cube. So our f of z is I z cube. Clear? Right students, so it is the way of proving harmonic function and finding the conjugate harmonic function and find the corresponding analytic function in terms of z. Okay, so I am repeating once again, please attentive. So the step number 1 is proving the harmonic function, that is dou square u by dou x square plus dou square u by dou y square equal to 0. Sometimes v is given, then you have to prove dou square v by dou x square plus dou square v by dou y square equal to 0. Okay, so according to given function you have to prove. So here u is given, so dou square u by dou x square plus dou square u by dou y square is equal to 0. That is the step number 1. And step number 2, finding harmonic conjugate. Harmonic conjugate means here u is given, so we have to find v. So we are applying the total differential formula, dv is equal to dou v by dou x into dx plus dou v by dou y into dy, and we are applying the Cauchy-Riemann conditions. In the places of dou v by dou x, dou v by dou y, you can substitute minus dou u by dou y and dou u by dou x. Okay, then we get dv is equal in terms of u. Okay, then we get v value by doing the exact differential method. In exact differential method, it is of the form mdx plus ndy. So the solution for mdx plus ndy is v is equal to integration of mdx, y treat as constant, plus integration of n dy, only the terms contains y, not contains the x. Okay, and at last we have to substitute f of z is equal to u plus iv. We have to substitute u and v in the places in f of z, that is u plus iv. If we want to find f of z in terms of z, in the place of x we have to substitute z, in the place of y we have to substitute 0. Okay students, it is all about finding harmonic function, proving harmonic function and finding the conjugate harmonic function and finding the analytic function f of z. We will do more problems in the next videos. So it is this is all about this video. If you like my video, please like, share and subscribe to my channel. Don't forget to click on bell icon so that you will get my new video notifications and share it to needy students. Thank you all. Bye bye. Your Sridhar signing off.